Let us now talk about ozone. As we all know, the formula for ozone is O3, which means it is a compound of one of the P block elements known as oxygen. And it contains 3 nascent oxygen atoms and hence also known as trioxygen. Before we talk about the preparation and its chemical properties and where all ozone can be used, let us first talk about its physical state. So ozone is found as a pale blue gas, dark blue liquid and a violet black solid. It exists in all the forms with different colors. And ozone is found in the atmosphere. And how is it formed? It is formed by heating of the oxygen by ultraviolet rays present in sunlight. Well, we know that ozone protects us from the ultraviolet rays, but at the same time, if the concentration of ozone increases, to above 100 ppm, it leads to headache and nausea. Okay. Ozone readily gets converted into oxygen, and this conversion is not a very thermodynamically stable process. There is an increase in entropy of the system, right, and liberation of heat. Now, do you remember from your thermodynamics class what is delta S and delta H values for such kind of a system? When heat gets liberated, delta H is negative or positive. And similarly, when entropy increases, delta S is positive, right? And when heat gets liberated, delta H is negative. Ozone can be prepared by passing electric discharge through oxygen, right? And 3 molecules of oxygen and 1 more atom of nascent oxygen combined to form ozone. It is an endothermic process, right? It's a reverse reaction, right? Since when ozone gets converted into oxygen, it's an exothermic process. Liberation of heat is there. So conversion of oxygen to ozone has to be an endothermic process. Now many students ask me this question, that if heat is required in preparation of ozone, why don't we simply heat up oxygen, right? What is the importance of this silent electric discharge? So friends, what happens is ozone decomposes in presence of even small amounts of heat, right? It gets converted back to oxygen, and hence we have to provide a silent electric discharge which provides some amount of heat energy to oxygen to get converted into ozone. So this is one of the apparatus. You can see these are tin foils. Oxygen gas is passed from here. These tin foils are connected with a high voltage, and when this current passes through this, the small amount of thermal energy that is provided to oxygen makes it get converted into ozone. Alright. As you all know, ozone readily decomposes into oxygen, and hence it is left with 1 oxygen molecule and 1 nascent oxygen. That is why it acts as a powerful oxidizing agent. Here we see lead sulfide being converted into lead sulfate by getting oxidized with ozone's oxidizing properties. Similarly, iodine ions in an aqueous solution of water, as soon as react with ozone, iodine gas is what we get. Liberated iodine is used to perform a quantitative test for ozone. Let us see how.